hello, and welcome to Solve with Solver episode presented to you by the Visual Appeal. I'm sure most of us have come across linear programming, non-linear programming, and other complex statistical problems sometime either during high school or undergrad. These problems still continue to haunt us in our everyday work. Be it a network optimization problem for trading, logistics company, be it a resource allocation problem for service company, or literally any cost minimization, revenue maximization problems revolve around these concepts. Let me introduce you to Solver in Microsoft Excel, which simplifies these complex statistical problems and helps us derive the answers that we want in just a click of a button. In this episode, we will begin by exploring goal seek function in Microsoft Excel. We will then apply this understanding to using Solver tool in Excel. All you need to have is Microsoft Excel downloaded on your computer and we are good to go. Like I mentioned before, there are several use cases to the Solver tool, but today we will be solving a resource optimization problem for Cheerful Inc.
Well, it's story time. Here are some facts about Cheerful Incorporated. It has three teams: the finance team, technology team, and the administration team. And each of these teams have an executive, a manager, and a director. All these folks are together involved in Project Cheer. There is a standard per hour rate card established by the company. So according to this rate card matrix, an executive in finance team costs $30 per hour. Executive in technology team costs $40 per hour, and so on. The goal here is to ensure that the total cost of Project Cheer is exactly equal to the budget, $50,000. So the real question here is how many hours should each of these employees work in order to achieve the target cost? Let's find out the answer using GoalSeek. What we have in front of us is Microsoft Excel, and I have incorporated the rate card matrix that we just discussed. You will notice that I have created an additional column called the team-wise cost, but I have not populated the numbers in that column as yet. We have to figure out number of hours worked by each of these employees to achieve the target cost. For now, you can type an imaginary number here. I'm going with 80 hours, but you can literally type any number of your choice. And imagining each of these employees work for 80 hours on Project Cheer, let's find out the team-wise cost. All we have to do is multiply cost per hour into number of hours worked. So I'm going to give an absolute cell reference for number of hours by hitting on F4, just so that it becomes easy for me to duplicate the formula to find team-wise cost for tech team and admin team as well. So I have here cost of an executive working for the finance team if he works for 80 hours. To that, I'm adding the cost of an assistant manager in a finance team. Again, I'm doing cost per hour into number of hours. And to that, I'm adding the cost of a director as well. Cost per hour into number of hours. And I'm going to select the three rows and I'm pressing Control D, which just duplicates the formula which is in the first line. To format these numbers better, I'm going to click on this comma symbol under the home ribbon and under the number section. And I'm going to reduce the decimal places to 0 by hitting on decrease decimal button right here. I'm going to hit it twice. All right. Now let's find the total cost by adding these three rows. I'm typing the formula equal to sum and adding the three rows, and we have the cost as 42,800 USD. Now let's use goal seek to find out the number of hours these employees work to ensure that the total cost is 50,000. We can perform goal seek analysis by going to the data ribbon. We see what if analysis under the forecast segment. We hit that and we see goal seek here. When you click on goal seek, a goal seek dialog box appears with three different parameters. You have set cell, to value, by changing cell. So in the given scenario, we have to set cell total cost, which is E11, to 50,000, which is the budget of Project Cheer. And we want to change the cell which contains total number of hours, right? So we say by changing cell B14, which contains total number of hours. When we hit OK, Excel does multiple iterations, and by trial and error method, it arrives at 93.45 hours. So let's hit OK. Goal seek found a solution. And now let's reduce the decimal point by going to home ribbon. We know how to do it. Let's reduce the decimal point by clicking on decrease decimal button here. And approximately each and every person should work 93 hours to ensure that the total cost of Project Cheer is 50,000.
Well, that was a very simple solution, right? But usually, employees across teams, across designations, don't end up working for the exact same number of hours. So, let's complicate this scenario a little bit and simulate a real life scenario by adding a few conditions or what we call constraints.
Here are some modifications made to the current scenario. The goal now is to minimize the total cost. So we no longer have the budget of 50,000 USD and we don't need to adhere to that anymore. Next, we have team-wise available hours. Finance team has 800 available hours. Technology team has 1,000 hours. Administration team has 300 hours. And each of these teams must fully exhaust the available hours. So the hours they spend on Project Cheer must be exactly equal to 800, 1,000, and 300 respectively. The third change is designation-wise maximum hours. So an executive has 800 available hours after taking into account his holidays, mandatory offs, and all of that. So the number of hours that he will spend on Project Cheer cannot exceed the available 800 hours. It should always be less than or equal to 800 hours. Same is the case for an assistant manager or a director. It has to be less than 1,000 or 300 hours. All right, now with all these complications in place, how do we solve to arrive at minimum cost for Project Cheer? Now let's see how to incorporate these conditions and constraints and arrive at the minimum possible cost for Project Cheer. We have the rate card per hour as usual. We have it right here. And what we also have is a template for hours. It's the same template as rate card, but it has an extra column which has total hours worked. And it also has an extra row which helps us compute total hours worked according to designation. So for hours, we don't know the exact number of hours each of these employees have worked on Project Cheer as yet. So I'm going to fill in an imaginary 80 for all the rows and all the columns. You can choose your favorite number, but I'm just going with 80. So I'm going to sum up according to designation and according to teams right here. All right, we have two constraints if you remember. So the total available hours per team is given in the question, which is 800 hours for finance team, 1000 hours for technology team, and 300 hours for the admin team. And there was a condition that the total actual hours worked must be exactly equal to the available hours for each team to eliminate their idle time. So this is constraint number 1. Let's also talk about constraint number 2, which is number of hours available per designation. Available hours. According to the question, we had 1,440 hours available for an executive, 850 hours available for assistant manager, and 400 hours available for a director. And we also discussed that hours worked must be less than or equal to the total available hours. I am going to go ahead and add another constraint. So I'm going to say that no employee can work for less than 8 hours on project cheer. So no employee can work for less than a day on project cheer, and that will be our third constraint. Now that we have all our constraints in place, let's compute total cost of project cheer, assuming each employee works for 80 hours. We know how to do that, so let's go ahead and multiply cost per hour into number of hours. So I'm going to multiply for each team. So I'm going to say 30 into 80 plus 55 into 80 plus 90 into 80. And I'm going to do the same for tech team. I'm going to say cost per hour into number of hours plus cost per hour into number of hours, and so on. Let's do that for the admin team as well. If you think the formula is too lengthy and it gets too confusing, you can use sum product formula. So a sum product function returns the sum of products of the corresponding arrays. So we will select array 1, which is the 3 by 3 matrix of cost per hour, and I insert a comma and select the array 2, which is again a 3 by 3 matrix of hours. So I'm going to close the parentheses and hit enter. It gives us the same answer. So either you use a sum product formula, or if you want to use, cost per hour into number of hours formula, you can go ahead do that. So we have the total cost here. For now, I'm going to retain just the sum product formula. You should always remember that to solve any question or any situation with solver, there are 3 parameters. The first one is called the objective function. So here our objective is to minimize total cost of project cheer. Then we have to set the constraints right. We have 3 constraints here. So the first one is the total hours constraint. Next is the available hours constraint. And the third constraint is that no employee can work for less than 8 hours. And then finally, we must have something called the decision variables. So decision variables are the variable cells that are used in computing the formula in the objective and the constraint cells. So here, all the ATRs that we keyed in are the decision variables. So these are variable cells that we used to compute our objective and constraints, right? So we have the three things: objective, constraints, and decision variables. We know what they are. Now let's go ahead and use solver. Go to the data ribbon and you will find solver in the analysis segment. In case you don't find solver in the analysis segment of data ribbon, all you need to do is hit file, select options, go to add-ins and select go, which is near the manage Excel add-ins. So I'm hitting go. And you just have to check the solver add-in right here and click OK. You will find the solver added on to your analysis segment of the data ribbon. Now select solver. Our objective is total cost cell. So I'm selecting cell B24 and my objective is to minimize the objective cell, right? So I've set the objective to total cost and my objective is to minimize the total cost. And I want to change the variable cells. So these are our decision variables. This is the 3x3 matrix. These are all the 80 hours that we filled in. And we know we have three constraints. The first constraint is that total hours worked by each team must be equal to. So in the cell reference, I select total hours worked. And there is a tiny drop down beside it. I'm going to select equal to. You can see the various options that are given right here: greater than or equal to, less than or equal to, integer, and all of that. And the constraint is that these cells must be equal to the total hours given. We hit on add. Constraint 2 is available hours, and total hours worked must be less than or equal to. We leave it as this, and the constraint is it must be less than or equal to the available hours. We hit on add again. And the third and final constraint is that each of these variables must be greater than or equal to 8. Now that we have all three constraints in place, let's select OK. We have an option to make unconstrained variables non-negative, which essentially means making all your decision variables non-negative. Here, our decision variables are number of hours worked by each employee, and I want it to be non-negative. I'm selecting this option. Before we hit the final solve, we have one last parameter to select, which is called the solving method. There is a drop down beside it, and let's explore the options. The first one is GRG non-linear, second one says simplex linear programming, and third one is evolutionary. Let's learn a little bit more about each of these solving methods. The first option in select solving method dropdown was generalized reduced gradient or GRG nonlinear. This method is used if our objective cell or the target cell does not contain references of the form variable into constant. If we have to explain using the current scenario, we have a constant rate card per hour matrix, and we have variable number of hours matrix, right? So our problem is in the form of variables into constant. But if you do not have a problem which is in the form of variables into constant, you will use GRG nonlinear. And you should always remember that there is a limit of 100 constraints when you use GRG nonlinear method. Moving on to simplex linear programming, this method is used to solve linear programs, which is in the form of variables into constant, which is what we are going to do right now. We are going to solve our current problem using simplex linear programming method. And there is absolutely no limit on the number of constraints when we use this method. Evolutionary method is used for most difficult types of optimization problems, which are non-smooth, discontinuous. Now that we know our current problem is a simplex linear programming problem, we'll go ahead and select simplex LP from the drop-down, and we'll hit on solve. Solver found a solution. We hit OK. And we see that the total cost is now 87,420, which is the minimum possible cost of project share considering all three constraints. And we also see the number of hours populated for each of these employees, for all teams, for all designations right here.
I really hope you guys have some takeaway from this video and you're able to create magic with Solver tool. While I go back and scout for another topic for my next session, happy learning and see you in the next video.